From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
One kind of unifying aspect is that the practical outcomes of it allow people to understand the technology across different disciplines. Right? So, of course, people with background in metallurgy or machine design or even business and economics don't necessarily embrace or want to embrace the same set of fundamentals. But if you can understand, here's why a 3D printed part is useful as a hip implant, or here's why this company used it in a particular fixture, or here's how 3D printing, made hearing aid manufacturing so much more efficient. We find that with our students, as well as with folks in industry that we interact with, the applications and the value proposition is kind of the unifier for people with different backgrounds and levels of experience. And then that also can motivate individuals to want to grasp enough of the technical principles to get the job done.
That was John Hart. John is an associate professor of mechanical engineering and Mitsu Career Development Chair at MIT. Prior to joining the MIT faculty in July 2013, he was the assistant professor of mechanical engineering, chemical engineering, and art and design at the University of Michigan. At MIT, John leads the mechanosynthesis group, which creates new machines, materials, and design principles for advanced manufacturing, including carbon nanomaterials, additive manufacturing processes, and origami-inspired materials design. John joins the show today to talk about education and the additive manufacturing industry. So John, thank you for coming on the podcast. It's an honor to have you. I know it's a busy time with getting ready for the new semester. For the audience, why don't we just get started with a brief introduction?
Yeah, hi Mike. Thanks a lot for the opportunity. Really excited to chat. I'm John Hart. I'm a professor of mechanical engineering at MIT. Been at MIT for about 7 years, and before that I was faculty at the University of Michigan in Ann Arbor for a few years, and before that did my graduate work at MIT. I've been a mechanical engineer through and through, and just started getting interested in additive when I came to MIT, and maybe that's part of the story that we'll talk about today.
Excellent. And what was the start of additive? Where did you first kind of come across it? What got you interested?
Yeah, well, so as a mechanical engineer, in some way, I've always been curious about 3D printing. You hear about it, you see it, and we all know that 3D printing's been around for a few decades. But actually, what got it all started was an interest in education. In particular, I was asked in my first semester at MIT 7 years ago this fall, I was asked by a colleague, Professor Dave Hart, to offer a new class, and he said you can pick any topic you want as long as it's within the realm of manufacturing. And it was going to be a small group of students, specifically about 15 students who were in our master's program in advanced manufacturing. And to make a longer story short, I said, well, what about additive manufacturing or 3D printing? To be honest, I didn't know much about it. I didn't know the details of all the processes out there or what I appreciate today, but I took it as an opportunity, with my broader interest in research and education, to learn about something new. Kind of winged it in that first semester, and that's actually where it all started. Led to having students doing research, led to some entrepreneurial opportunities, led to a lot of great interactions with industry, and it was one of those, you could say, pivotal moments in a career that you don't know really why you're making this choice or what lies ahead. But I look back on that as a key moment, and it really does come to education as kind of a core mission for what I do most days.
And I suppose too, full transparency, I was an undergrad at MIT at one point, for those listening. And when I was there kind of in the early 2000s, I think, and I have probably a slightly different perspective because I was in materials, in the materials department. The focus on additive from kind of a holistic perspective has really, really grown in terms of all the courses that you've done, your research. And can you talk a little bit about how maybe the perception or the activity going on campus has grown alongside the industry?
Yeah, so certainly in my time at MIT, I've seen the interest in 3D printing and related topics grow incredibly. So across the institute, you have students using 3D printers for so many different purposes, right? In coursework, in projects, in research, right? The 3D printer is a tool to create instrumentation to help, chemistry research, biology research, et cetera. It is really, really there. Also, we've seen many faculty understand the broader implications and how fundamental research in many fields has an implication or a context in future manufacturing. You could say additive, you could say digital manufacturing more broadly, and that's materials design, metallurgy, computation, AI, precision machine design, robotics and automation, and so on. And I think, and like many places, right, we have a critical mass of faculty and students who are, really interested in understanding the hard problems in the field, and also, how we can help industry forward through our education programs, and also, how we work in our research.
So going back to your first master's class that you taught on the technology, what were some of the things that you learned from teaching that first course that helped you influence? You've got, we'll get to kind of talking about your online course and some of the other courses you've done along the way, but kind of in doing it the first time, what was the thing that stood out as wanting to continue down that path?
Yeah, I mean, great question. I think one important element in hindsight was that I was teaching this class to a room of students who were there to study manufacturing. And that's not to limit any other field or interest, but this is a group of about 15 master's students who come to learn deeply the principles of manufacturing at the graduate level. And they often have a few years of experience beyond their undergraduate, typically in industry. And therefore, the mission of the class was to talk about the fundamentals and applications of 3D printing, but in a manufacturing context. And through our discussions and through the projects, we thought about manufacturing issues. Like, I remember one of the projects that was proposed and done by a group of students was studying how to post-cure parts from the Formlabs machine. Now, interestingly, that was when Formlabs was just shipping their first machines. And we were able to convince them to get us a little bit closer toward the front of the line with respect to their Kickstarter backers. And we got, among the first Form 1s. And this group of students wrote a report and did tests post-curing the parts. So if you know stereolithography, you take it out of the printer, it's not done, and then you have to put it in an oven or put it in sunlight even, and post-cure it to give it its finished mechanics. And that was one of the projects. It was not inventing a new 3D printing process, but was understanding basically the process fundamentals, the process variables. And in that long-winded answer, I mean to say that I think thinking of additive in the context of manufacturing was an effective way to sort of frame where it stood and where it needs to go to be a production technology. And amazing strides have been made since then, but we all realize we're still at the early stages, and there's lots of important challenges to overcome.
Assuming from kind of your standpoint as an educator, professor in the space, the multidisciplinary nature of 3D printing, additive manufacturing makes it both fun and challenging to think of ways to communicate the technology and engage with students.
It does, but I think one kind of unifying aspect is that the practical outcomes of it allow people to understand the technology across different disciplines, right? So of course, people with background in metallurgy or machine design or even business and economics don't necessarily embrace or want to embrace the same set of fundamentals. But if you can understand, here's why a 3D printed part is useful as a hip implant, or here's why this company used it in a particular fixture, or here's how 3D printing, made hearing aid manufacturing so much more efficient. We find that with our students, as well as with folks in industry that we interact with, the applications and the value proposition is kind of the unifier for people with different backgrounds and levels of experience. And then that also can motivate individuals to want to grasp enough of the technical principles to get the job done.
Yeah. And so let's see if I have the timeline right. So you had the master's course that you were teaching on campus to graduate students. then you also had a summer course, is that right, as well, to kind of professionals? And then was it the online class, and a lot of the research is kind of going
Yeah,
on
exactly. Like
concurrently? Is
one
that
thing
what's
led. Yeah, sorry to cut you off a bit there, but yeah, exactly. One thing led to another. Started with a graduate course on campus at MIT, and then taught a 1 week professional course. MIT, like many universities, has a professional education a department. Where as faculty you can set up a short course for industry and offer it over the summer. It was starting to meet companies with interest in working with us at MIT in 3D printing. And I proposed the class, offered the class, had a room of about 40 individuals come for a week the next summer, taught the class again to students. The next year it was a little bit bigger, did more projects. And then one thing led to another, ended up launching an online course now about 2.5 years ago, complement to in-person experiences. But that was an effort to think about scale. To think about how can we create a high quality course that can be delivered at scale to large numbers of people. And we've had roughly 5,000 professionals take it in the past 24 to 36 months, where I think we're on run number 7 or number 8 now of the course.
That's amazing. And within each of those cohorts of students, I'm guessing you have different perspectives of how people are either coming to the technology, thinking about it, or even hoping to use it in their career. And what's kind of the difference, I guess, that you're seeing in the sense of, maybe let's just start with some of the master students that you're teaching, and undergrads and graduate students that you're working with on campus, versus some of the ones who may be taking it from an online perspective.
Yeah, I'd say that many people bring different perspectives or different elements of useful background to AM. So maybe one, you could say the stereotype about additive you hear some people say is, well, it's all about the next generation, right? It's the young people right now that will understand truly how to, design the amazing stuff that we've never thought of before. In some cases that may be true, but when you interact with industry, you realize that there's so much, existing expertise in every corner of the field or of the automotive industry, aerospace industry, medical industry, that combines with AM to really understand the cool problems that can be addressed. And the collaboration of people, as you said before, across disciplines or across generations, in many cases, leads to new ideas. So we've seen, in our summer course, one time there was a high school student from Turkey who came and learned with the professionals, 10, 20, 30, 40 years his senior. And we've worked with teams of individuals in our online course, in some cases hundreds, at individual companies across different divisions of the company. In other cases, smaller groups or teams that come together across different industries, and they get to know each other and bounce ideas off one another for the case studies and projects.
And being an online course, what's it like kind of translating something that's often very physical, like manufacturing's in a warehouse, in a facility, your hands dirty often, and you're actually designing, and what were some of your thinkings and approaches when you're trying to communicate the technology and going in as much detail as you guys do in the course?
Yeah, I mean, to be honest, I think it's impossible to replicate hands-on learning in an online format. There's nothing like, including with 3D printing something yourself, or walking through the prototyping, lab at your company. That said, I think we've realized we can go a long way with a multimedia, good quality video, close-up photos, and 3D examinations of parts, giving our learners access to software, to cloud-based CAD and topology optimization, generative design software, and asking good questions, asking, not only kind of, do you understand the facts and fundamentals questions, but reflective questions that promote creative thinking and brainstorming. And in some instances of the course, we've shipped out little decks of brainstorming cards. In other instances, we've shipped parts. And I think it's gone a long way to bringing a little bit of that hands-on element to a digital course. In other words, I think with the tools we have, right, for digital interaction nowadays, while you can't replicate what it's like to be actually building something yourself, you can get an experience that's much richer than just watching something on video. And that was one of our goals from the start. And now we're actually getting into some virtual and augmented reality type experiences that hopefully can complement. Another element that I think was important is just capturing the whole workflow. So having videos, we connected with Proto Labs and went down to one of their facilities in North Carolina, and they took us through the whole workflow of all their processes. And you saw, how the machine is loaded, what the printing looks like, what the removal looks like, post-processing, et cetera. And we want to talk about the end-to-end, which we know is so important to actually, understand how to get your finished part. And that was a pedagogical principle of the course that I think has been a good one.
Right, and you mentioned Proto Labs and Form Labs and others, and I think throughout the course and your teachings and things I've seen, you've been involved with online, and I've even been fortunate to participate in some brainstorming sessions, as well as really the outreach and partnership with industry to bring them in not only as students and participants, but also in providing that information into the course and giving case studies and perspectives. And how's that journey been in terms of engaging folks in the specific industry sectors?
Yeah, it's been absolutely essential and instrumental to our course and our what we do at MIT overall to engage and partner with industry, right? And in the class, we can only go so far with the fundamentals, right? What is the force it takes to extrude this plastic, or how does the laser interact with the metal powder, et cetera. There's a lot of great material we've captured from industry and they've offered, and you realize how many great examples there are, and how I think you can augment an education by combining the practical, the proof is in the performance example, with a story of how it came to be and what is a little bit of the science and the engineering behind it. And also our philosophy is that our course is, to be honest, a little bit deep and a little bit rigorous, but that rigor imparts understanding of what's necessary to sort of break through the acronyms and headlines and learn how these different processes work and how you can compare them and understand the properties that result, and what are a lot of the key design and performance considerations. And we like to go all the way to cost modeling and business considerations as well. And we've seen how engineers are really excited about that stuff, because you get to see a bit of the business economic side, and also I think there's few places where you're able to effectively put the two together.
And from people taking the course, what sort of feedback do you get in terms of what their role ends up being in the companies that they're already in? And are they leading additive groups? Are they engineers and design, or transitioning over, or kind of looking for new roles? Where do people find the most value of the course and in kind of their practical everyday job functions?
Yeah, and honestly, we've had the whole spectrum of roles engaged, but by and large, everyone it takes the course because they want to know more about additive. They have some role or aspiring role. We've seen many of the former participants go on to lead initiatives, small and large. Some work at startups, service bureaus. Some are sales professionals. Others are really, advanced engineers, or managers, or business leaders. A little bit, you name it. One of the we've done a few, you could say, special instances of the course. Like normally when we run the course, anyone from any company can sign up. But in some cases, companies have reached out to us and said, hey, we want to put a few hundred people through this course. And we just set up another copy of it digitally. And then you have a separate cohort. So in one of those organizations, a big automotive company, they brought together a few hundred individuals from many different business units as an effort to also encourage cross-disciplinary collaboration in additive. But it's hard to say that like everyone seeks or gets a promotion or a job change because of knowledge in AM. But I think we've certainly seen that it's a tool for advancement. And I'll probably never forget one of the participants in the first run of the course was so eager in the discussion boards and so helpful in giving feedback to others. And he was a tooling engineer at a small company. I think he ended up now leading AM for a big multinational corporation, and it was a big career jump. And I know that our course was just a little part of that for him. So it's great to see those stories and see how, as we think about, how do we as a world, evolve our technological capability, and how do we value learning and development, right, lifelong, to see that courses like this have an impact on career growth, I think that's the biggest impact we could hope to have.
Absolutely, that's tremendous. And kind of bringing it back to on campus, how does kind of additive manufacturing fit into the education for students at MIT?
Yeah, so there's a few I guess good examples there. First, actually the main course I teach at MIT is not additive focused, but is manufacturing processes overall, taught to our juniors, mostly juniors in mechanical engineering.
2007 or is it
2008?
Oh, okay.
So it's the MIT has funny course numbers, as you know. So course 2 is mechanical
close.
engineering.
I was in course 2, so the one I was here.
Yeah, and 008 means that it's the 8th of 9 required courses for the standard Mackie track. But it's machining, thermoforming, injection molding, casting, additive, et cetera. And therein, what we've done is made 3D printing, kind of a tool in the box of manufacturing technologies we discuss. And also we use it in their project, which for a long time has been the design and manufacturing of yo-yos. The students work in teams and they do the sketching in CAD and CAM and mold machining and injection molding and assembly of 50 to 100 yo-yos a team. And we use AM for rapid prototyping, desktop machines. We use it actually to make soft tooling for thermoforming. And it's been really interesting to see how the students have responded in terms of the creative freedom and quick turn you have to make a plastic, thermoforming die. And you get to do some error analysis and so on. In the future, who knows, we might do some metal mold tooling, not quite there yet in terms of cost or accessibility, but importantly, we see the importance of understanding AM in the manufacturing context, even if it's just in the context of the machine shop. And we ask them to do, a part of one of their final deliverables for their yo-yos is to do a cost analysis that's broken down into different categories, and we ask them to think about the cost of 3D printing, with some spreadsheet-based tools and external quotes that we get from contract manufacturers also. And like in the industry course, I think a unifying theme is be motivated by the practical impact, be motivated by the application, and that excites interest in the in a little bit of theory and fundamentals as well.
Right, so they get hands-on, kind of real-world application of a business case and connecting that to the actual manufacturing process, which I think is really valuable. I mean, and you can take the theories off the page and off the textbooks wherever you're getting them, but once you have the CAD design in your hand and are getting real world quotes and lead times and all the complications that come into it, it's certainly a good learning experience. And I mean, I guess from thinking about MIT as a whole and from the additive sense, like, so there's a number of courses that you guys are teaching, but what about kind of fundamental research on new technologies or new materials and new approaches? Has that been something that's grown? Certainly historically, there's been several printing technologies that have roots at MIT, from Z Corp and some of the Formlabs folks and others, but is there a centralized kind of effort, or is it kind of distributed across many different groups and professors and initiatives?
Yeah, I mean, I'd say a bit of both. There's probably a few dozen faculty working on aspects of additive manufacturing as parts of their research, including myself, and that includes new machine and process concepts, ways to do metrology and quality control, metallurgy, advanced characterization. As well as sort of cool new concepts in design and human machine interfaces. And some of that work by nature is just a faculty member and their students. There's a lot of work that's collaborative. I work closely with a couple of colleagues in material science on aspects of metal additive that combine equal doses of metallurgy and alloy design with processing, with you could say the manufacturing side. And then we do have a consortium of companies focused on additive and digital manufacturing. We call APT, that engages a group of us on campus to advance strategic dialogue with the members and support some of our courses, and also support some sort of seed level early stage research. And we kicked that off about a year ago, and now we're really just getting it off the ground. We also have support from some of the members or companies. Some honestly pay to be part of the consortium. That's how it works. Others who make equipment are kind as their membership to donate or loan us equipment, and that's going to be put in a couple new 3D printing labs that we'll have on campus that are complementary to our core research labs, but also for teaching and you could say more applied development.
Excellent, that's amazing. And as you think about kind of the courses that you've done and are continuing to build and improve on, where do you think the biggest opportunities or gaps remain in getting information out to people and users and hopefully new members of the community?
Yeah, well, maybe first of all, I'd just say that dissemination of good quality, like learning at scale, I think is really important, right? In so many areas, these days, right? Pandemic aside, teaching the world is something that I think we all can always do better on. But in respect to AM, like I maybe my number one is the importance of quality control and being able to understand these processes at a level that allows their output to be predicted, engineered, et cetera. And that's, as that's a really hard problem for any process, any machine technology, but we've also seen the great strides that the industry is making, right? Software tools, workflow, some of the stuff your company is doing, understanding of the materials and the fundamentals of the process, smarter machines, better software, and so on. And I can kind of, I feel like we can see the future to where you could actually have a full digital thread to get a part made, to particular mechanical spec, to particular dimensional spec. And we can do that already, but the level of work that it takes to achieve that is so high relative to what it will be or could be in the future. And I think that's a way to roll up a lot of the research components that promote industrialization of the technology, or enable what I'd say is true industrialization at a scale that's 10x, 100x, you name it, beyond the footprint of AM today. One more quick comment. I also see the huge potential for materials and innovation, and that's been maybe the case for a long time, but even more so now. The design or formulation of specialty materials, new alloys, and the symbiosis of them with the AM process. I felt it like metals recently. There's a little bit of a turning point beyond just the conventional alloys to special formulations that are suited to AM or can have better properties, rather than the reverting to just a conventional formulation, because that's what industry is used to in other contexts. And I think that's really important. And it also speaks to the value of data in the value chains and business models, because when we say everything is connected digitally, we say, well, how do you think from a business perspective of capturing the value of that? And there's lots of interesting questions and evolutions on the commercial side there.
Right. I mean, no shortage of topics to cover, and I think, both areas are very close to my heart on the materials and quality part. But if people are interested in kind of looking into the course more, or getting to know more of what MIT is doing with additive, I think I'm guessing you have a course coming up this semester online at least, and where else? Where should they go, or where should they look to find more information?
Yeah, thanks. So there is an upcoming run of the online course. It launches September 21, I think, and you'll get there if you go to additive manufacturing, one compound word .mit.edu, or you just Google MIT X Pro additive manufacturing. X Pro is the office that runs the online course with us, and also for my research and for our consortium, it's apt.mit.edu.
Awesome. Well, thank you so much for your time today, John. I know it's getting crunch time and the start of the semester, and really appreciate it, and look forward to continuing the dialogue and seeing what your team continues to put out in research and new courses.
Thanks a lot, Mike. Take care, and thank you all for listening.